go ahead and start talking through this well work. So first thing I need to do is figure out the number that's going to go in the box over here. If I'm using synthetic division, how do I find that number? How do I find the number that's going to go in the box when I use synthetic division? Yes. So I'm going to take this x plus 3, sorry, x minus 3. Set it equal to 0. Then I need to get the x all by itself, so we add 3 to both sides. Cancel. X full. This right here. I'm gonna put 3 over there. How do I get the other numbers? Bring them down. Okay, so what is the biggest exponent here? 3. So I need the coefficient on x cubed. What's the coefficient on x cubed? What's the number in front of x cubed? 3. Then I have to go to x squared next. What's the coefficient in front of x squared? -7. Then I need the coefficient in front of x. -11. And then I need the constant. What's our constant? 15. All right, so I've got that piece of it set up. Then I need an equals bar here. And I need that little leg. Usually broke this guy off from everybody else. Because over here is going to be my remainder. All right, so I'm ready to start this process now. I've got it all set up. What's the first thing I do once I've got it all set up? Bring the 3 down. Now, something that I did notice as people were doing synthetic division, we don't just want to bring it down here. We need to bring it all the way down below the equal sign. I'm going to bring 3 all the way down here. And then what do I do with these two numbers? Multiply them. 3 times 3 would give me 9. Now I write that down right here, and we're going to add it to the number up above it. What is -7 plus 9? 2. And then one more time. 3 times this value right here. We multiply these together. 3 times 2 gives me 6. I write that down right here. Add it to the value up above. -11 plus 6 gives me what? -5. One last time, I take the 3, we multiply it here. 3 times -5? -15. Add it to the value right above it, and that gives me a remainder of what? A remainder of 0. So if I was going to write this down as an equivalent expression, I need to make use of these numbers right here. What's the meaning of the 3, and the 2, and the -5? What would I put with them? So do I just put x here? No. X squared, because it goes down 1 degree. This one here had been an x cubed. It drops a degree. So with the 2, what would I put? Just an x, and that -5 is my constant. So an equivalent expression would be 3x squared plus 2x minus 5. That right there answers the question fully. All right. We are going to dig into your new notes. I do want to point out on this one that on the module 4 test, I gave you guys extra credit if you took it one step further. What did I ask you to do after this? Find the roots. So we would factor that. We would draw our x and our box, and we would factor that. That's actually one of the things that we're gonna focus on doing today. So the thing that we're gonna be learning today, for the most part, you guys have already done. We're gonna focus on two main skills today. The first one, again, is something you've done. We just haven't used this name for it yet. So the first thing that we're going to talk about is something called synthetic substitution. When I use synthetic substitution, I can evaluate when x equals 5 by doing synthetic division with this 5 here. So I would put this in the box. Do my synthetic division. And then what I want is this remainder. In module 4, we wrote our remainder as a fraction, but when I'm doing synthetic substitution, all I want is the remainder for my answer. This is exactly the same as if I took 5 and I substituted it into my expression. When I do synthetic division, that remainder gives me the exact same thing as if I substituted it in directly. So this piece right here is what goes in the box. And then the answer that I'm looking for is my remainder. This is called the remainder theorem. It's a way of substituting in and evaluating without doing direct substitution. So I want to practice that. Look at example number 1, down at the bottom of the page. First thing I need to do is set up my substitution. So we're going to evaluate f of -3. So this right here is what goes in the box. So that's where they got this -3 from right here. And then we bring our other numbers over. I want you to look at those numbers carefully. How many terms does my function up here have, f of x? How many terms does it have? How many things separated by pluses and minuses? 4. How many numbers did they write down? They wrote down 5. Why? There's a 0 in there. Why is there a 0 in there? They don't have an x cubed. So right here, there is no x cubed, but we need every power of x represented. So this means that there is 0 x cubed. We start with x to the 4th. That's this -2. That's x to the 4th. And then we have to go to x cubed next. And since there aren't any, we put a 0 in there as a placeholder. And then we have our x squared. We have x. And last but not least, we have our constant. Okay, so once we get all those numbers in there, we're going to bring that -2 straight down below the equal sign. And then we start multiplying. -3 times -2 gives me what? Remember, we're multiplying 6. And then I add these together. I add the 0 and the 6 together, and I get what? I get a +6 because I'm adding 0 plus 6. I get 6. Multiply -3 and 6 together. -18. I add that to the 3 that's above it. What do I get when I add 3 and -18? -15. Multiply again. -3 times -15 gives me what? Remember, I'm multiplying. Negative 3 times negative 15 is 45, yes. Then I add the negative 15 and the 45 together. 30. One more multiplication to do here. Negative 3 times 30. Negative 90. And I add that to the value up above. What do I get when I add those to together? Negative 81. This is my remainder. And when I'm using synthetic division to evaluate, all I want is that remainder. So here's my final answer, f of negative 3. If I take negative 3 and I substitute it into my function, so this part goes in the box. This is what I'm substituting in. I would get negative 81 back if I were to evaluate that directly. That's the exact same thing as my remainder when I do my synthetic division. So far, so good? Great. I want to do one more of these together to make sure that we got all the pieces, and then you guys are going to try a couple of these on your own to make sure you got it. Go ahead and flip the page over for me. We're going to start with, what piece do I want to put in the box? I want 8. Why do I want 8? This piece right here. And then I want the other numbers, the ones that don't go in the box. What's my biggest exponent? X cubed. What's the coefficient in front of x cubed? Negative 6. Then I need x squared. 52. Then I need x. Negative 27. And then I need my constant. Negative 31. Draw my equal sign. Cut the remainder off from everybody else. This is going to be the only thing that I care about over here. Right. I'm going to bring that negative 6 straight down below my equal sign. And we're going to multiply. What is 8 times negative 6? Negative 48. So I take 52 plus negative 48. 4. The 48 is not as far away from 0, so that's why I have a pocket. If I have $52, I spend 48, I still have money in my pocket. Yep. All right. Now I need to do 8 times 4. 32. Add that to the number up above. Get 5. Then I do 8 times 5, and I get 40. Add that to the number up above, and we get what is our remainder? 9. So f of 8 evaluates to 9. Here's my remainder. The questions marked 1 and 2 right below this, I would like you guys to do on your own. Take about 4 minutes and then we'll go through those. get to the remainder on number one? Look at it. First thing we need to do is pull this one straight down. I'm not answering. We're gonna go through it together. I multiply -3 times 1 and I get what? -3. We're gonna add that to the value up above. What is 2 plus -3? -1. And then I take -3 and multiply it to the -1. Negative times a negative gives me what? Positive. So I have a positive what here? +3. I add that to the value up above, and what happens? I get a 0. Am I done though? No, still need to multiply again. -3 times 0 is what? 0. And I add that to the value up above, which gives me my remainder of 1. Yeah, that would change it. Negative times negative there. So we get a remainder of 1. What did you guys get for the remainder on number 2? Look at that one. Drop our 1 down first. I'm gonna take -3 times 1, and that gives me what? -3. I add -11 and -3 together. If I owe Jaden $8 and I owe Shadrach $3, how far in debt am I? So this is gonna be a -11 here. -11 when I add -8, -3. Then I multiply a negative and a negative again. -33. Yes, +33, thank you. +33, which I'm gonna add to the 6. And end up with a remainder of what? 39, yes. So f of -3 on this function evaluates to 39. All right, let's try one more problem like this. And then we're gonna switch gears and we're gonna talk about something that we've already done before, but we're just gonna give it a formal name and then we'll practice with it a little bit, okay? So example number 2. This is an application for our remainder theorem. Says that the total production of eggs in billions in the United States can be modeled by this function right here, where X is the number of years since 2000. So the number of years after 2000. We want to predict the total production of eggs in 2025. So how many years have passed? 25 years. We're going to do 2025 minus the year 2000. So this right here is what we're going to put in the box. So that we can determine f of 25. Copy our coefficients down and go through our synthetic substitutions. The first thing I do is I drop that 0.007. I'm going to multiply that by 25. What happens when I multiply that by 25? What do I get? 0.175. I'm going to add that to the number up above it. So negative 0.149 plus 0.175. Zero point zero. So forth. Each of those digits is off by 1. Not 36, but 26. There we go. Yes. 0.026. I'm going to take that now and multiply it by 25. we get 0.65. And add that to the number up above it, so 1.534 plus 0.65. 2.184. Multiplication one last time. When I multiply that by 25, get 54.6, absolutely. Add that to the number up above it to get our remainder. $139.355 is my remainder. All right, so using that, let's answer the question. You're gonna need one of each of these. Got the remainder here. So in 2025, approximately how many billion eggs will be produced? $139.355. Awesome. Okay, so that's our first big idea for today. We're still doing synthetic division. We're finding our remainder just like we did in module 4, only now we know that that remainder is the same thing as taking that root or taking that value and substituting it into our function. Second big idea for today is called the factor theorem. This is specifically when my remainder equals 0. So when the remainder equals 0, then x minus the number in the box is a factor. When the remainder equals 0, then x minus whatever the number in the box is a factor of our polynomial. We practice writing factors, we practice writing things in factor form before the break. Now we know if we have a 0 when we do our synthetic division, that is a factor. And then we can take what's left over and factor it further. I've had you guys practicing this already, and I had mentioned only works like this when our remainder is a 0. This is why. All right, go down and look at example number 3. Go down at the bottom of the page. They asked me to do 2 different things here. First, they want me to show that this is a factor. And what are the second part of the directions there? What else do they want me to do? Yes. Then find the remaining factors of the polynomial. All right, so for the first part, I need to set up my synthetic division. Why do they have a -8 in the box here? Why isn't it a +8? Yes. X plus 8 equals 0. Minus 8 from both sides. That's how we get x equals -8. This is what we put in the box. So that's this piece right here, and then we write down our coefficients. Please make sure that you have every power of x. in your homework packet, I know that there's at least one problem where they skip a power of X and you have to put a 0 in there or else you'll get it wrong. Right, so we bring our 2 straight down, and then what do? Multiply -8 times 2, that gives me -16. I'm gonna add that to the number up above, and that gives me a result of what? -1, yes. -8 times -1 gives me what? +8. You add that to the value up above. -3. One more time we multiply. Negative times a negative. I get a +24. I add that up above and we end up with a remainder of what? Remainder of 0. All right, so here's how I answer the first part of the question. I have to write it down like this: the remainder equals 0. Therefore, x plus 8, because this is where I got that -8 from, x plus 8 is a factor. Right, there was a second part to this question. What was the second part to the question they asked me? They want me to find the remaining factors. How do I find the remaining factors? Factor what? I like your answer, but what am I factoring? Yes, okay, so there's 2. What goes next to the 2? X squared. Is it always x squared? No, it drops down 1 degree. This 2 right here came from x cubed. We dropped a degree, so then -1x. And my constant is right here. 2x squared minus 1x minus 3. We need to factor this for part 2. All right, so I'm going to draw my area model. My box. And I'm going to need an X. I put A here and C here. What's our A term? 2x squared. What's our C term? -3 minus 3, yes. Up on top of the X, that's where we have to multiply A and C together. So what numbers am I multiplying together? 2 times -3. What is 2 times -3? -6. So I need 2 numbers that multiply to give me -6, but add to what? -1, my B value. What multiplies to -6 but adds to -1? -3 and 2. And when I put those into my area model, I have to put x's back with them. So I have -3x and +2x. And then I look at just 2 boxes at a time. So I'm looking right here first. What do 2x squared and -3x have in common? What goes into both of them? What do they have in common? X. Anything else? 2x and -3, what do those two have in common? 1. +1 or -1? Positive, because this box here that it's touching is 2x, is a +2x. So there's a factor. Then we're going to go vertically. 2x squared and 2x, what do they have in common? X, anything else? 2. So 2x is what they have in common. And then negative 3x and negative 3, what do they have in common? Negative 3. All right, we are ready now to write down our factors. Number 2, or the factors. There was one factor that we found, we verified at the beginning. What was the factor that we verified right at the beginning? Negative 8 is my root. What's my factor? Not positive 8. Factors have x's and parentheses and pluses or minuses. So close. X plus 8. This is what we wrote down right here. X plus 8 is a factor. So x plus 8. What were the other factors that we just found? X plus 1. 2x minus 3. Right. So that right there answered both parts of the questions that they asked us. Do a little bonus here. If those are my factors, what are the roots? So I have 3 answers and they all have to be x equals. X equals, what was the first one?
X equals
negative 8. That was one of the ones that they gave us at the beginning of it. We found at the beginning. How do I find the other 2?
So set equals to 0.
Set them equal to 0. So I had x plus 1 equals 0. 2x minus 3 equals 0. Now I have to solve each of these for x. So I would minus 1 from both sides. So x equals negative 1. And for the other one, what do I do here first? What do I do first? Not minus 2x. I want to get the x all alone, so I'm going to leave the x there. Add 3 to both sides. And I have 2x equals 3. X still isn't alone yet. Divide everybody by 2. So I get x equals 3 over 2. Or what is that in decimal form? $1.5. So there's my bonus. I want to do one last problem with you guys today. So flip the page over. That thing that we did for bonus, that's what we're after here. So first we have to verify that this is a factor so that I know I can factor the result. Then we'll factor it and we'll find our roots. The first thing I need to do is figure out what is going in the box. What goes in the box? 3. Take this thing right here. Set it equal to 0. I would add 3 to both sides. X equals 3. Put this in the box. What's my biggest exponent? The biggest exponent. X cubed, yes. What's the coefficient in front of x cubed? 1, so I write down a 1. In front of x squared? Negative 4. In front of just x? 1. And my constant? 6. So my equal sign. Cut off the remainder from everybody else, and I need this to be what, or else I'm stuck? I need this to be a 0, or else I have to stop. I cannot find all the roots unless my remainder is a 0. I bring the 1 straight down. Multiply the 1 and the 3 together and get what? Multiply the 1 and the 3 together. 3. And add that to the number up above. I had a -4, so now it's -4 plus 3. -1. We're going to multiply and get a -3, absolutely correct. Add those together, you said I get what this time? -2. One more time with multiplying, 3 times -2 gives me what? -6. When I add that up above, I get a remainder of what? A remainder of 0. Love my remainder of 0. Okay. So can I keep factoring this? Is it possible? Yes, that's what my factor theorem tells me, is that when I get a remainder of 0, I can continue factoring. So what am I going to be factoring? Yeah, 1x squared minus 1x minus 2, my constant. So x squared minus 1x minus 2, we're going to factor this. I need my area model, box. X. A here. C here. What is A and C? -2 is C. Yep. A is a 1x squared. When I multiply those two together, and I get -2. What is my B value? -1, right? What multiplies to -2 and adds to -1? 1 and -2. Don't forget to put the x's back on them when you put it inside the area model. For -2x, positive 1x, let's see what we have in common. X squared and 1x, what goes into both of those? X. -2x and -2, what do they have in common? -2. So there's a factor right there. X squared and -2x, they have in common what? X. And 1x and -2. 1. Positive or -1? Positive. All right, so let's write down our factored form now. How many factors did we find? 3. Where's the third one at? Way up at the top, x minus 3. So x minus 3 was a factor. What were my other two factors? X minus 2 and x plus 1, but we were asking to give what as our answer? The root. Factors never have equal signs inside them. Roots, I have to have equal signs. I'm going to have x equals for each one of these. So what are my x equals? X equals what? 2. X equals 2. X equals 3. -1. Yes. How do we find those again? Set the factors equal to 0, yes, so x minus 3 equals 0. X minus 2 equals 0. X plus 1 equals 0. This is how we found those roots. We're gonna stop here for today. There is something that I need you to fix on your homework though. So if you'll pull out your homework packet, I'll show you what it is that you need to fix on there. On the second page, it's problem number 6. All right, on problem number 6. First of all, do you see where it says positive? Totally cross out the word positive. And then here, this underlined word possible, we're gonna change this. We're gonna change to maximum. And minimum. Maximum and minimum. So that's the change that you need to make on this. So how many answers are you gonna have here? 2 answers. You're gonna select 2 of these choices here, one for the maximum, one for the minimum. Don't worry about the word positive, just scratch that out. And possible, we're changing to maximum and minimum. One last reminder for you guys, this Friday is December 2nd. That is the last day that I will accept any late homework. Any homeworks, any reviews, corrections, retakes, all of that has to be done by this Friday. Right? Because next week, we're gonna be doing for final exams, and I have to have time to get all that paperwork answered. And then the week after that, we take your final. Let me see the final exam, let me pull that final exam schedule up. Give me just a moment and I'll find that for you and I'll let you know.